that shed light on the importance of metainference and metainferential standard when characterizing a logic, or more in general, a theory, if one thinks that the valid inference are part of the theory, how to characterize a theory. So in order to illustrate my point, I will briefly discuss the case of ST, which is a non-transitive logic, and explain why ST supporters should better say something about metainference and metainferential standards in general. But actually, my point can be extended easily to every mixed logic. So this is the outline. I will be introducing these notions of metainference and metainferential standards. Then I will present the thesis that I want to discuss, and then I will present the case of ST and display this small argument. Then I will end. So, what are metainference? By inference, I just mean a pair of sets of formulas. Okay, the ones on the gammas are the premises, the deltas are the conclusions, and a metainference are just like inference, but instead of relating sets of formulas, they relate sets of inference themselves. So the premises of a metainference are inferences, and the conclusions are inference also. And of course, this notion can be extended at least to every finite level. So a metainference of level n for every finite n is just an inference that relates metainference of level n-1 as premises and metainference of levels n-1 as conclusions. There are other ways to characterize metainference that admit hybrid ways that admit like metainference of different levels as part of the premises or the conclusions, but for what I want to state here, it's not necessary. And also it's possible to extend metainference to transfinite levels, but also there's no need to do that here. So when a metainference is valid, well, there are many ways to understand when a metainference is valid. The one I will favor in this talk is the local way to understand metainferential validity. That is a natural extension of the way to understand validity for inferences. When is an inference valid in a mixed logic? At least a mixed logic is one that is characterized that can be characterized using two standards, one for premises and one for conclusions. So an inference is valid in a mixed logic L1, L2, if and only if every evaluation that satisfies every premise according to the standard L1 confirms or satisfies the conclusion according to L2. Here, in the inferential case, L1 and L2 are sets of truth values. So, for example, the K3 is the paracomplete logic K3 is a mixed logic, and in that case, one can define K3 in a three-value setting, and both L1 and L2 are just the set that contains just the value 1 as its only member, and one can also characterize in this way the paraconsistent logical P. In this case, both L1 and L2 are the sets that contains both the value 1 and 1/2, but the more interesting cases are the ones that where L1 and L2 are different. And in particular, I will be focusing on the case where L1 is just the set of that contains only the value 1, and L2 is a set that contains both the value 1 and 1/2. That logic is known as ST. And I will be talking a little bit more about that logic later. So a natural way to extend this notion to the metainferential level is in the following way. So a metainference is valid in a metainferential logic L1 and L2, or is valid according to the metainferential standard of level n L1 and L2, if and only if every valuation that satisfies every premise according to the standard L1 also satisfies or confirms at least one conclusion according to the standard L2. Here, L1 and L2 are satisfaction standards for the previous level, satisfaction standard for for meta-inference of level A-1. So in both cases, both in inferential and the metainferential case, validity is understood as preservation of validity. But of course, the standard according to which one can evaluate whether a premise or a conclusion satisfies or just not satisfy is or is not satisfied by evaluation may vary from premises to conclusions. And in the metainferential case, the evaluation satisfies an inference or a meta-inference if and only if it is not a counterexample to its validity. Okay? So this is the thesis that I want to discuss. Can a logic or a theory be defined just by a satisfaction standard for inferences? Can a logic, or more properly a logician, be agnostic about meta-inference or meta-inference or about the metainferential standards? So I want to discuss this thesis because I found that it's initially plausible. A possible answer to this question is initially plausible. Actually, I was initially inclined to say that yes, one can just adopt, for example, the logical P for the inferential level and be agnostic about higher levels. And this is a thesis that is supported by Dave Ripley. So this is a quote by Ripley paper. He says, note that a counterexample relation for inferences, which is just a satisfaction standard for inferences, a standard that says when an inference is or is not satisfied, on its own says nothing at all about the validity of meta-inferences of any higher level. Despite this, there is a tendency to move quickly from X to the full counterexample relation determined by X. So Ripley is saying that there's a tendency to confuse a satisfaction standard for inferences for a list of satisfaction standard for meta-inference determined in some specific way by the standard for inferences. And he goes on to say, for example, Chris Campbell says, absent any other reason for suspicion, one should probably take the full counterexample relation to be what someone has in mind when one only specifies X. Ripley says that this tendency is not warranted. Most of the time when one speaks of satisfaction standard for inferences, one does not have the whole world of higher level meta-inference in mind. Though I do think that usually when people talk about a satisfaction standard for inference, usually have something like the full counterexample logic fixed by that standard. I will not argue for that. I just want to defend that we should have something like that in mind. One thing, of course, Ripley is correct in the following sense. When one speaks of a satisfaction standard for inference, one needs not to have in mind nothing about higher level standards. But when one supports, my point is the following: when one supports a satisfaction standard for inferences, one better have some commitments about higher levels in order to avoid unpleasant results, in particular triviality. Specifically, I think that a logician should better ban some metainferential standards in order to avoid triviality in the inferential level. Okay. So I think the following position should be abandoned. And once again, I will quote Ripley. He says, an advocate of ST, which is a particular mixed logic, as a useful logic for inferences, that is a meta-counterexample relation of level 0, has thereby taken on no commitments at all regarding higher level meta-inference, the suitable standard for higher level meta-inferences. If one specifies just a meta-n consequence relation, they have not thereby settled on any particular higher level consequence relation. So the first quote just state his points for the first level. He says, well, one can be committed to ST to be the correct logic for inferences, and not having any commitment at all regarding which meta-inference are valid. And the second quote just extend this point to every level. One can be committed about a particular satisfaction standard of level n without taking any commitment at all regarding the next level. So I will argue that a supporter of a particular satisfaction standard of level n should better say something about, or have something in mind, or ban at least some higher level satisfaction standards in order to avoid triviality. So this is my argument is pretty simple and is the following. If a supporter of a non-trivial inferential logic X need not take any stance at all on which metainferential standard is correct, then anything goes for a supporter of X and at the metainferential level. So she could be fine with any metainferential standard. But if anything goes for a supporter of X at the metainferential level, then she can also accept a metainferentially trivial standard. But a metainferentially trivial standard is also an inferentially trivial standard. This is what I want to defend here. Therefore, a supporter of a non-trivial inferential logic X might also be committed to the validity of every inference. It's not that she is committed, but she might be. One cannot no longer describe a supporter of a non-trivial logic X as not being committed to the validity of every inference. So let's explain this with the case of ST. So ST is usually characterized as this strongly logic that captures every classical validity, in the sense that an inference is valid in classical logic if and only if it's valid in ST, while also being able to be non-trivially expanded with either a one-half constant or a transparent true predicate. So it is usually admitted that a central feature of ST is that cat is invalid either locally or globally. The local notion is preservation of satisfaction. The global notion is preservation of validity if a one-half constant is added to the language. So they avoid triviality by not having ST in their sequent calculi, or by making cat invalid either locally or globally. Nevertheless, if ST only pronounces, if ST is just a satisfaction standard for inferences, this is no longer true. In the end, it will depend on which standard for meta-inference is adopted. And if no constraints are imposed, then this can no longer be concluded. And moreover, as I put here, things can turn awkward easily, in the sense that one can infer triviality in inferential level, but this is just an extreme possibility, of course. We can still say that ST validities in a suitable expanded language are not closed under cat, but in order to conclude from that the cat is invalid, one have to admit that an ST supporter is also committed to some metainferential criterion after all. So, and if ST is just its valid inference per severely globally valid rule, then that's okay. But these guys are not the ones I'm arguing with, because they do have some validity criterion at the inferential level. So setting these thoughts aside, I'll try to argue for something stronger, that in order to avoid inferential triviality, in order to avoid triviality in inferential level, a supporter of ST should at least ban some satisfaction standard for meta-inference. And in order to, this can be shown in many ways. The way that I will show that this is possible is in a particularly strong way. I will be introducing two satisfaction standards that make possible to define a trivial metainferential standard. And the two standards are the following. So let that sign stand for the empty set, and that sign with a line on top stand for the set of every true value in a three-value setting. So an inference is valid in this, according to the standard or according to this logic that we may call everything nothing, if and only if every evaluation that gives one true value to every premise gives a member of the empty set to the conclusion. Of course, this is an empty logic because no inference will be valid in it, and moreover, it is particularly strong because no valuation will satisfy no inference. And this is the other satisfaction standard that I need to introduce. I am calling it nothing everything. Is the result of switching the standard from premise to conclusion from the previous logic. So an inference is valid in this logic, nothing everything, if and only if every evaluation that that gives a member of the empty set to every premise gives some true value to some conclusion. And of course, this is a trivial logic because every inference will be valid in this logic. And moreover, every evaluation will satisfy every inference. So why do I care about these two standards? Because with them, it is possible to define this metainferential standard that has the first logic or the first standard, everything nothing, and the standard for premises of metainference, and nothing everything as a standard for conclusions of a metainference. So a metainference is satisfied by evaluation in this, according to this standard, if and only if the evaluation satisfies every premise according to everything nothing, then it satisfies some conclusion according to the second standard, nothing everything. And of course, a metainference is valid in this logic if and only if it's satisfied by every evaluation. And what happens is that this is a metainferentially trivial standard or a metainferentially trivial logic, because every metainference of level 1, with or without premises, this is key, will be valid in it. Okay, so every metainference whatsoever, with or without premises is valid according to the standard. So if the inferential standard is related in no way to the metainferential standard of validity, then a supporter of ST might also be a supporter of this guy at the first metainferential level. So if Ripley position is correct, if one can support ST without taking any commitment at all about the inferential level, that anything goes at that level, anything it is possible. So it is possible to combine ST at the inferential level with this thing at the metainferential level, which is metainferentially trivial. So now let's define SDstar, which is the logic that has ST as a standard for inferences and this guy as a standard for metainference of level 1. If Ripley is right, then a supporter of SDstar should also be counted as supporter of ST, because in order to be a supporter of ST, the only thing that matters is that one supports ST at the inferential level, one thinks ST is a correct logic for the inferential level, then one can also be a supporter of this guy at the metainferential level. But as this logic validates every metainference, it also validates every empty premise metainference, and in particular, it validates every empty premise metainference with just one conclusion, which is an inference. Okay, thus it validates every inference, at least if this thing that I call the equivalent thesis is true, which says that for every inference phi and the empty premise metainference that has phi as its only conclusion are either the same or equivalent things. this I take it to be a very intuitive, very plausible thesis. So an inference can be thought of either an inference or a meta-inference with an empty premise set and with an empty set as premises, and that inference as its only conclusion. And they should be equivalent in the sense that evaluation should validate one if it validates the other, and one should be valid if and only if the other is valid. But the problem is that SDstar is not only metainferentially trivial, but also inferentially trivial if the equivalent thesis is true. Because despite having ST as a standard for inferences, it not only validates everything that is valid in ST, but it also validates every meta-inference with an empty premise set and only one conclusion. And if those things are equivalent to inferences, then it also validates every inference. So it trivializes at the inferential level. Okay. So to avoid triviality, one obvious move is to admit that the equivalent thesis is not true, not true after all. So in fact, I don't think that the equivalent thesis is true after all. So this presentation can be understood as a reductio of that thesis. But if we stick to the equivalent thesis, which I repeat, I think is a pretty standard position and moreover a pretty intuitive position, then meta-inferences matter after all if we want to avoid triviality. A logic should, or a logician better, should pronounce about meta-inferences in the sense that at least not that she should be committed to one particular standard at metainferential level, but in the sense that she should ban some unpleasant options to avoid unpleasant results. That might be triviality or something not as bad as triviality, but also unpleasant. So in particular, one cannot support ST as a standard for inferences while also supporting this thing as a standard for meta-inference of level 1. So one can say, well, a supporter of ST should also ban this thing as a standard for meta-inferences. And I think this is correct, but we need a reason for that. And non-triviality as a desideratum might not be enough, because one can go into trouble even without even avoiding triviality. I can talk more about that in the Q&A section. So are just meta-inference of level 1 the only meta-inference that matter? Can we stop here? Because I have just presented an argument to prove in a way, if I'm correct, that meta-inference of level 1 matter. Can we just stop here? Can a logician be just a supporter of something in the inferential level and something in the metainferential level while being agnostic about higher levels? The short answer is no, because this move can be replied all the way up. This means, in a nutshell, this means that for every non-trivial mixed satisfaction standard of level n, there is a a trivial satisfaction standard of the next level, of the level n+1, such that if the equivalent thesis is true, then it also trivializes the n level. And if this supporter of the standard of level n take no commitment at all about the next level, the n+1 level, then one can no longer describe this supporter of this standard of level n as a supporter of non-trivial sets of meta-inference of level n, because her position might be combined with this trivial position on the n+1 level. Here it says that I will show the details in the next slide, but I won't do this. I will skip this and go to and conclude. Okay. So as a conclusion, to sum up, every metainferential level matters when characterizing logic. You have to believe me, because I haven't shown this, but I have this result at least. Thus, it is not enough to pronounce about what is valid in the first metainferential level. If these problematic cases should be avoided, then a logician should also pronounce in some way about every metainferential level. I repeat, not in the sense that she should be committed to a particular metainferential standard in every metainferential level, but in the sense that she should at least ban some things. This conclusion does not change if we adopt other notions of metainferential validity, if we adopt a global notion, if we understand metainferential validity as preservation of validity, or an absolute global criterion for metainferential validity, which is this other thing that people are talking about. But I will not explore this path here. And even though I have just shown this for ST, I think this is a problem that faces every strong clean logic. And moreover, I think that many other mixed logic, at least. So that's all. Thank you.